Okay, we want log of e to z to be equal to z, and it's not. It's just not true. Can we fix it up? Yes, we can fix it up. We can fix it up, but the fix is not in the text. I'll give you a reference later, make sure that it's available on OWL. And what turns out to be true is that the log of e to the z is not z, but it's z minus 2 pi I times an integer. And the integer is called the unwinding number. This equation is equivalent to saying that z is equal to logarithm of e to the z plus 2 pi I times its unwinding number. And that's because when you take the logarithm of z, you restrict it, the logarithm of anything. This z is different from that z, sorry. The logarithm of anything is restricted to be in this range. So if you start with something outside of this range, take the exponential and then take the logarithm, you start in some other strip, you go over there and you come back to this strip. And the difference is only going to be an integer multiple of 2 pi I. It turns out that we have another formula for the unwinding number. If you take the imaginary part of z and you subtract pi and you divide by 2 pi, so you get a real number here, because the imaginary part of z is a real number. Subtract pi, it's a real number. Divide by 2 pi, it's a real number. And then you take the ceiling of that. So that's the integer, the nearest integer that is larger than or equal to this. So for example, minus pi, the one that gave us problems in the example of e to the minus I pi, if you take the imaginary part of minus I pi, that's minus pi. Minus pi is minus 2 pi. You divide by 2 pi, you get minus 1. This factor allows us to fix up this equation. So if we start with minus I pi, e to the minus I pi is minus 1. Log of minus 1 is pi I. So we get I pi there. We don't get minus I pi. Minus I pi is I pi minus 2 pi I with the minus 1 from here. So this factor, the unwinding number, allows us to computationally and predictably fix up this relationship. So I'd like you to be aware that this relationship exists. I'd like you to be aware that there is such a thing as the unwinding number. I'd like you to be very aware that when you're simplifying logarithms of exponentials, that you don't get the function here unless the unwinding number is 0. Sometimes the unwinding number is 0. If the imaginary part of z is less than or equal to pi, and it's bigger than minus pi, then this number minus this number, the ceiling will be 0. And so when the unwinding number is 0, that's a special region of the complex plane. Some of us like to call it the clear-cut region, just because we've got logs and clear. Anyway, never mind. I didn't invent that joke, but actually I kind of like it. The key point is that log of e to the z is not z unless this number is actually 0.